Okay, this is another type question. This one's actually talking about the forces in it, and it's about forces that are in equilibrium or point of slipping or the verge of movement. So the particle is held in equilibrium, that means no motion, by a horizontal force, magnitude h newtons, as shown in the diagram. The line of action of the force lies in the vertical plane containing the line of the greatest slope. So it's actually just saying we are looking through a single cut through. There's no funny angles in it. We're strictly dealing with a two-dimensional problem. The particle is on the point of moving up the plane. Find the value of h. Now this particle is the same as in a previous video. So the particle has a weight of 4g newtons, and mu for the surface is 0.3. What we've got to try and work out is how big is h. So I'm going to do the same thing as I did in the previous one, which was a SUVET question. I redraw my model, and come in, and now it said, let's put in my force, and again, if that's 30 degrees there, 30 degrees to the normal is between the weight, and notice the weight is the hypotenuse of this circle, the weight vertical, and we got the weight horizontal, and we got 30 degrees in the middle. We got a reaction force, and at right angles to this force coming in, so at 30 degrees to the plane, we have h newtons. Just want to check. Up. So this time, notice it's the attempted motion is to move it up. And if that's the attempted acceleration, my friction is about to go there, is to act backwards. And as we're on the verge of motion, on the point of slipping, we actually have F equals mu r. On the limit of equilibrium. So there's my diagram with some extra forces added to it. What's that doing zoom now? Okay, just had to sort out my keyboard. For some reason it was zooming rather than moving. So let's put our equation vertically first, and it's a vertical resolution. So we're going to resolve our equation vertically. I'm going to say positive is up. We've got an awkward thing here that we've also got the h has a 30 degree on it as well. So there's no motion, so we get 0. Vertically no motion is equal to the reaction force minus the weight vertically and minus the height, the h force vertically. H vertical. So r minus 4g cosine of 30 minus h sine of 30 is my first equation. Horizontally, first of all, we say friction equals mu r, because we're on the limit of motion. So resolve vertically, now resolve horizontal. I'm going to say horizontal is in the direction of motion, A. Our acceleration is going to be 0, because there's no motion still. What forces have we got acting in our direction? Well, we've got the horizontal part of h pushing towards we've got the horizontal part of our weight acting backwards, that piece, and we've got friction trying to stop me from sliding up the slope. So H cosine 30 minus 4G sine 30 minus mu r is equal to 0. And now we need to solve these equations simultaneously. So make the two things equal. So we can make the two things equal so we can actually draw our question. So now we're going to make these two things equal because they're equal to, dangerous to say they're equal to 0, but yeah. R minus 4G cos 30 minus H sine 30 equals H cos 30 minus 4G sine 30 minus mu r. I'm not sure we can, yeah, we're not eliminating nicely, so we need to get rid of the r. So we multiply all of this by 0.3 and we place my mu r. So from that one, mu r equals mu times 4G cos 30 minus H times H sine 30 plus sine 30. So we can replace that into this part of the equation. 0 equals H cos 30 minus 4G sine 30 minus mu 4G cos 30 plus H sine 30. And if we rearrange them, we can get all the H's together. So H cos 30 minus mu H sine 30 minus 4G sine 30 minus 4G cos 30 with mu. Rearrange things so that we get the H's together and separate it out. Minus mu sine 30. And we've got the 4G on this side. 4G sine 30 minus mu cos 30. These values have been worked out before, so we've got H equals 4G times sine of 30 minus mu cos of 30 all divided by cos of 30 minus mu sine of 30. If you plug your numbers in and solve for it, we should get H to be 41.6 newtons.